Good morning, ladies and gentlemen from Germany. We are happy here today to talk about hybrid electric vehicle and especially the apprenticeship in that. On my right side, that's Daniel Brown, good friend of mine and colleague. He's an expert for hybrid electric vehicle, worked for Toyota many years, and as well is an expert for worldwide qualification, especially on hybrid and electric vehicles. So Daniel, what will we see today?
Morning, Chris. And good morning, good afternoon to everyone around the world. Looks like we've got people from all around the place.
Yeah, we're just hovering through the list. So we see names from the Asian region, European region. So great to have you here. A lot of people are already in.
Feel free to let us know where you're watching in from in the chat. So on the chat there, you can just let us know some general information, but we've also got a tab here, Q&A. So if you've got any questions about what we're talking about today, hybrid electric vehicles or any of the equipment that we're going to show, you can write that down in Q&A.
Absolutely. Feel free to put questions in all the time, but we will answer them after the video.
Great.
Perfect. Okay, so like we said, we have a lot of people here all over the world. And what is very interesting for these people, I think, my friend, is what about the qualification hybrid electric vehicle? At first, why it's so important to get a qualification or to be trained as an expert for hybrid and electric vehicle?
Sure. So we're all used to seeing qualifications for light vehicle technician. That's something that a lot of countries around the world have some sort of qualification for light vehicle. And that's where the normal technician, mechanic that's working in a dealership or a garage fixing vehicles needs to have.
Could you name a few countries which have an actual hybrid vehicle qualification?
Well, I'm just talking about before that. Okay. So normal light vehicles. So that's what we're used to now. General run-of-the-mill vehicles, conventional petrol, diesel engines, things like that. But now what you're talking about is the hybrid electric vehicle. So sure, hybrid electric, what's the main thing there? We're talking about high voltage. So now we're talking about vehicles that don't just have petrol or diesel. They also have large batteries with hundreds of volts. And, you know, if we're talking about electric vehicles, they've got very large batteries with mostly lithium and can be, if you don't know what they're doing, quite dangerous. And so a lot of countries, so here in Germany, Australia, the US, England, all have qualifications for hybrid and electric vehicles. So that goes on top of the normal light vehicle qualification.
To become an expert and to learn about all the safety standards, how you can protect yourself, what is special about hybrid electric vehicles, what is special about the high voltage system, and how to deal with the high voltage system. So, but what about the countries? Just let's assume, of course, it's not only the countries which have a qualification system, which want to train their apprenticeships on hybrid electric vehicles. What about, for example, about the countries which have nowadays not their own hybrid electric vehicle qualification, but even when the schools there, the training centers in the different countries also want to train high voltage experts?
Sure. So that's where we're working together with IMI. So they're a UK-based organization, Institute of the Motor Industry. We have a very close partnership with them. And so they're the only organization around the world that can offer international qualifications for hybrid electric vehicles.
That sounds amazing.
It is amazing. So we've had a lot of interest from countries that don't have their own qualification system, and they're actually looking at taking on the IMI international qualification.
Okay. And
of course, that's what we've brought into our training systems as well. So one of the systems that we're going to have a look at shortly, the CarTrain system, which we've both been involved in with the development and the writing of the courseware, is fully compatible to the IMI qualifications. So the way it's been in the past is a lot of schools will work with either textbooks or they'll get the real equipment, like a real vehicle, for example.
But we know with the textbooks it's a bit difficult nowadays because we are now in the century of digitalization, of animation, of videos, and especially if you want to show how the inside of the high voltage system works, it's quite difficult to do that by a book, isn't it?
Absolutely. So yeah, we'll see some of the animations in the video that we're going to show shortly. But another thing which is occurring is the technology is changing so quickly. So the problem obviously with a book, once you've bought the book,
yes,
it's
already
almost out of date straight away.
Yeah,
so
exactly.
That's one of the first problems as well. The other problem that we have, especially with high voltage, is working with real vehicles is it brings in certain problems for schools, having high voltage vehicles in the schools. We've spoken, both you and I and other members of our team, spoken to plenty of teachers around the world that are really scared to have high voltage vehicles with students, inexperienced students especially. So it can be a big problem.
Let's have a quick chat if this, let's say, fear, it's serious or if it's necessary. Of course, we all know a hybrid electric vehicle is designed the way that it's absolutely protected and it has this kind of intrinsic safety.
Mm-hmm.
But when we talk to the teachers, I think what we find out there is, of course, it's not about, we're not talking about, or we are not worried about hybrid electric vehicles in a good state, in a safe state. But when it comes down to damaged electric vehicles, or when we're going in that, or coming in touch with the diagnosis and doing diagnostics on the car, there is a problem. Of course, what do you think about, let's pretend you have a Toyota Prius or something like that,
mm-hmm.
like a brand new car at the training center, and you want to do diagnosis on that. So what kind of problems could you experience? What about when someone get an idea like, back in the day, we just integrated a lot of faults inside the combustion engine or inside the CAN bus or something like that. What about when someone would do that with a high voltage system? Like, let's say, hey, Daniel, let's do some faults into the high voltage system of the car.
That can bring up a couple of issues, actually. So one thing is, I was actually at a school in Malaysia one time, and they had some cars that were prepared for training from Korea.
Okay.
And we had a look at the car, and there was direct voltage connections onto the high voltage battery. So you could measure every cell across the battery. And we had a bit of a look at that, and you could literally measure with a voltmeter over 200 volts at the battery. There was no protection whatsoever on it. The metal, like you could, if you really wanted to, you could put a piece of metal in there and short out or touch the 200 volts of the battery. So we're
talking about the voltage, about what amperage are we talking then, for example?
Hundreds of amps.
Okay.
So it's, it'd be
so
devastating.
So you'll have no chance.
No. The second problem is, of course, when you have these type of vehicles and something goes wrong. And we're not saying you shouldn't have vehicles. You should absolutely have vehicles, but to do everything with the vehicle, try and understand how technology works. Using a vehicle is not necessarily always the best way.
In the first place.
Yeah, so understanding basics and things like that is obviously what we're recommending here.
Absolutely.
But what we found in other places as well, that for a Toyota Prius, for example, removing the inverter, we've been to places where the students have accidentally threaded the bolts, or destroyed the thread, and all of a sudden that whole car is now out of action because the inverter is not able to get put back onto the vehicle properly. So now all of a sudden you've got a complete car which is not,
and it's basically broken. You can't use it anymore.
Absolutely.
Or we just think about the situation. I mean, what is one of the most important parts or the most important actions on a high voltage system? It's the shutting down process. And what kind of issues can you experience? Just let's say you are doing an assessment where 10 people or 15 people have to shut down the high voltage system in a row. So what could happen basically after you have shut it down 10 times and then the next person is coming to the high voltage system? I think we have experienced something here in Germany before. I don't know if you can remember, but yeah, what could be the problem in that case when you try to shut it down quite a few times after each other?
Well, I remember we had one vehicle when we were doing some testing on, when we were doing our research, and we were doing the shutdown procedure and seeing how it works. And eventually the car just says, okay, that's enough. And especially if you're opening interlocks and things like that, if someone's not doesn't know exactly what they're doing, eventually the vehicle will just say, okay, that's enough. And with the level of scan tool that we had, it wasn't able to go into the next level to really delete the codes. We had to wait a while before we could get that vehicle running again there as well.
So basically what could happen there is that the vehicle completely shuts down and you have to contact the car manufacturer and get in touch with the official dealer in order to put the car back in ready state, basically. So we all know what that would mean for the assessment or for the training. You couldn't go on with the car. Luckily, we will talk later about that after the video. This couldn't happen with our software, with our hardware, with our training system. Before we get to the video, just let's sum up. So we have on the one side this very powerful partner, which is called DIMI, which is completely responsible, or who's completely responsible for the electric vehicle qualification. I think we are right now at 4 different levels there, including first responder training and all that.
Right.
So that means we have the complete qualification on the one side, and on the other side, we have aligned our LN training system with that different qualification levels. So all in all, what we have created here is like a one-stop solution for hybrid electric vehicle.
Absolutely.
And the training system, which we're going to see now, it is about, so what's the name of it?
It's the CarTrain hybrid electric vehicle, but we're also going to show the heavy vehicle version as well,
which is called TruckTrain. Then you see it there, CarTrain for the light vehicle, TruckTrain for the heavy duty vehicle. So, and now we start with a video where you see one CarTrain out of 2. So the other CarTrain will be presented for the high voltage battery later in the week. But this is like the first step for your hybrid electric vehicle qualification and to become a high voltage expert.
Don't forget to send us your questions in the Q&A section as well.
We wish you a lot of fun with the video and see you after it.
Okay, today's video is about hybrid electric vehicle training. What I'm going to do today is show you some of the solutions that are out there in order to bring over the complexity of these high voltage systems, but also to do that in a safe manner. So reducing the liabilities for the teachers and the schools out there. While the endpoint is to be able to fix and repair these high voltage vehicles, we're going to need some different options to get the students up to that level. And so that's what I'm going to show you today with our new CarTrain systems from Lucas Nuller. Okay, so these are the 2 systems that I'm going to show you today for high voltage training. So first of all, we've got the TruckTrain system here looking at heavy vehicle high voltage systems, plus also the CarTrain system for looking at light vehicle high voltage systems. So this is our solution for trying to understand how high voltage systems work, but also doing it in a safe manner. So if we have a look here, we're able to have a look at the various types of modes. For example, here we've got 5 different types of hybrid and electric vehicles that we can show within this system. And that's simply a matter of changing the overlay mask that we see here we can simulate different types of vehicles. And in this instance, we've got a Toyota Prius that we're showing here on the interactive display. Okay, so we can start the system like normal and have a look as the system boots up, going through a preload phase as it would in a real vehicle. Once we're in ready mode, we can drive the vehicle and have a look at the energy flows. That's very hard to see on a real vehicle. So for example, driving the vehicle through different driving strategies, uphill, downhill, and in regeneration mode, we can quite easily see the different types of energy flows that you'll see on a real vehicle. We can also, going through our e-learning software, LabSoft, we can start to do many experiments that are related to the different types of training needed around the world for high voltage vehicles. So going from the different types of vehicles, why we have electric vehicles, to different types of electric vehicles, how to identify electric vehicles. We go right through into how the electric vehicles work also. We also have an overview of the experiments that are available on the system. We can see here there's over 40 experiments, including diagnostic tasks that we can do on this system.
Okay, of the various experiments that you can do, we can go in here and see what some of the real life voltages are that you would see on a real vehicle. So here's an example of the experiments and how you would do the experiments. Step-by-step guide is showing the students how they can undertake the experiment. So there's no need for the teacher to be there at all times. Okay. So from here, we can plug up our measuring devices, call up the measuring device, and we can see here that we're at 305 volts, so seeing the real high voltage that you would on a vehicle. Some of the other experiments that we can do here, we can also have a look at how the three-phase motors work in an electric vehicle. So going down to another chapter within the e-learning, we can see the theory behind how a three-phase motor works. So for example, one phase, two phase, three phases, and we can see how a magnetic field is being produced through a coil. And then on the third phase, we can see how a rotating magnetic field, which allows that motor to turn, basically the rotor within the motor. Okay, so we can see how that's done in theory, but we can also see how it's done in practice as well. So again, pre-prepared experiment. How can we do that? This time we're using an oscilloscope. Change to the appropriate settings. Oops. And there we can quite easily see how a three-phase motor is being driven by an inverter on a modern vehicle. What we can also show on the vehicle is how to perform diagnostic procedures and fault finding on high voltage vehicles. You can see here we've got an integrated fault switches with 7 different faults ranging from motor faults, battery faults, inverter and insulation faults. So simply clicking on here, I've put in an example on what to show for insulation fault. You can see now we've got a yellow fault within the system. Okay, so now once we've got the fault within the system, we can go into the integrated scan tool and it gives us here a real fault code, P309, high voltage leak to ground on one of the motor generators. So now we have to see which one of the motor generators has the fault. So what we're going to do in this situation now is to show the students how to perform an insulation test. But in order to do that first, they need to do an isolation procedure. So in this case, we have all of our safety equipment ready. So for example, wearing glasses. We also have our safety lockout box and padlock here. And also our gloves. So high voltage gloves. In this case, we're going to use leather over gloves as well. There's a number of things that we need to test first with our gloves is to make sure that they're first of all in good condition, which these ones look like they are. We also need to make sure that the date is within date. So when was the last time they were tested? And we fall within 6 months there, so these are okay to use. Plus we also need to do a test to make sure that they don't have any obvious holes in them. So test them, make sure we can't hear or feel anything. That one seems okay. And the same on this side as well. So our gloves are fine. Okay, what we need to do from there is take the ignition key and put that inside of our box. And disconnect the 12-volt system. And we also need our measuring device. So in this case, we need a category 3 rated multimeter so that we can measure the high voltage. And we're also going to use this one because it's an insulation tester at the same time. So one of the first things I need to do is make sure that our measuring device is working. So in this case, I want to go along and measure our 12-volt battery. So we need to make sure that our measuring device is actually working. So I'm testing that on the 12-volt battery here, and we can see that we've got 12 volts at the measuring device. So that's telling me that this guy is working. So I'll put that down to the side here. Now this is when I put on my gloves with the overgloves on top. And I'm going to remove the service disconnect here now. And now we put the service plug also into the safety lockout box, and we can lock that box away to make sure that no one else can start this vehicle while we're working on it. The key then belongs on my body so that no one else has access to that box now. Okay, so the vehicle has now, 12-volt system has been isolated, and we've also removed the service plug. And now we remove the cover for the measuring point so that we can measure to see if the high voltage has dissipated. I'm also going to do this one-handed. That's showing that the system has now gone down to 0 volts, which is safe, but we want to make sure that our measuring device is still okay. So I'm going to come back to the 12-volt battery